And bien. All right, so chapter 6 of microbial nutrition and growth. What this chapter is going to be about is what it takes for a cell to have metabolism, what has to be present, what the environment has to be like. Now, it comes right down to nutrition. Microbes, bacteria, fungi, all of them, well, they're going to need nutrients. They're going to need to take up their nutrients from their surrounding. Okay? Even if they're photosynthetic, they need to take up some nutrients. So you're going to have your macro and your micronutrients. Macronutrients, things they're going to need in considerable concentration. Micronutrients, also known as the trace elements. These are going to be things that are going to need to be required in minute quantities. A lot of times it's going to be heavy metals of some sort. Turns out you actually have some gold, some silver, some zinc in you. So you need to take those in your diet. So when you look at what's there, say E. coli cell, it's going to be composed of, the normal things that we think of when we talk a living cell. Proteins, nucleic acid, carbohydrates, lipids, and a few other things here and there. But the elements, look at the table here for table 6.1. The predominant element in a E. coli cell is carbon. Remember, I've said it before. We are carbon-based life forms here on planet Earth. So it means carbon is going to be the primary atom in everything that makes us up. Look down at the bottom, the trace metals, 0.3%. That's going to be the metals and things like I mentioned. Now, when you go and you look at microbes, you're going to see microbes generally going to fall into either autotrophic or heterotrophic. Autotrophic, think photosynthetic. They're going to need sunlight, or they're chemotrophic. Chemoautotrophs are a big one you're going to see at the bottom of the ocean. At the sulfur vents, taking in inorganic compounds. 7 miles down at a thermal vent when it's sulfur and methane coming in, or sulfur dioxide coming in from the center of the planet. No sunlight down there, but it's teeming with bacteria. Why? Because they're not photosynthetic. They're not using sunlight. They're not using a carbon source. What they're using, sulfur. And then things that are heterotrophic. Chemoheterotrophs are the one we're going to focus mostly on. Chemoheterotrophs, just like us, have to take up their carbon sources from outside. They use organic molecules for the basis of metabolic energy. So the chemoheterotrophs, textbook says, derive carbon and energy from organic compounds. Remember, organic compounds. These are going to be compounds that are based on carbon. It's going to be a carbon skeleton there somewhere. It's the carbon-carbon bonds are a lot of time where the energy's at. It takes energy to form carbon-carbon bonds. Thus, when you break them, you get some of that energy back. We find chemoheterotrophs fall into two subcategories. Saprobes, like we talked about with the fungi, who live off of dead things. They're the decayers. They're the ones that break down the detritus that falls to the forest floor or to the bottom of the ocean. And then when it comes to the microbes that are chemoheterotrophs, it's going to be the parasites. They're going to be the ones who, take from the living. We think of these in this course as pathogens because they infect, they do damage. So, as you see from table 6.3 here, the main elements, carbon, hydrogen, oxygen, nitrogen, all have different sources, all have different roles, and are going to show up in different organic molecules within the microbes.